we're going to look at functions as opposed to relations. Right? The idea here is that in a function, there is exactly one and only one output for each input. And the outputs are the y values and the inputs are the x values. So this shows a function when each x has one y that it results in. Here, this x has two y values. So this x, if you plugged it into something, say it was a 3, and then you got a 5 and a 12 out of it, then this would not be a function. This would be a relation, but not a function. This one here is a relation also. In fact, a relation, meaning the x and y are related in some way, is like a bigger group, and functions are a subgroup of it. You have functions as a subgroup and non-functions as a subgroup inside the relation, the overall relations group. Now, an example of one that is not a function is, first let's take a parabola like this. Every x value along here has only one y value. This x value goes to here, and that has a y value here. So every one of these points, each x value, there's only one y value that matches it. However, if I go like this, if the parabola is going sideways, if I take this x value is here, there's an x and there's a y there. And this one, if I go down here, every x on this line is the same. That means now there's an x and then there's a different y. It's this y that's here as opposed to this y that's here. So in this case, there's one x. Let's call that, say this is 5. And then this would be, say, 5 and 2. And this is 5 and -4. Well, the x is being used twice, but it gets different y values as a result. In fact, I'll make those my 5, 2, and -4 to match this. So in this case, this one would be a relation, but it would not be a function because at least one of the x values has two y values. So this next part is as if it was from in the textbook. You have to know that there are these different ways to show a function. There's using coordinate points, there's making a table, there's doing mapping, there's making an equation, and there's graphing it. So let's take using these points. These coordinate points here, we're going to use them to fill in the other things. But this can show a function. However, it can as long as each x value has only one y value. So we're going to put them on a table. I'm going to use the x of -3 matches the y of -1, 0 and 1, 3 and 3, 6 and 5, because that's the x and the y, the x and the y, and so on. Now, in mapping, we would do the same kind of thing. First, we'll list the x values, and then we'll list the y values, and then we would match them up. The -3 matches with the -1, the 0 with the 1, the 3 with the 3, and the 6 with the 5. Sometimes the range ones look like they're out of order and we might have to do a diagonal line. There's nothing wrong with that, right? Just in this case, it is they do happen to match directly across. Now, even though these here don't necessarily make a line because it doesn't include every single point in between, we're going to I'm going to state that they are part of a line as opposed to separate coordinate points. That allows us to take the table or to take any one of these methods and to make an equation out of it. And so for the equation, we're going to put it in the form of y equals mx plus b. It's slope-intercept form. And what we're going to do is we're going to find the two missing things. We need to find the slope and we need to find the y-intercept. Well, let's come back over to, or actually I'll use the space underneath it. The slope is equal to, we have to pick 2 points and we're going to take the x of one minus the x of the other. Oh, wait a minute, I made a mistake. It's y's on top. Be careful not to make that mistake like I was about to make. It's always the y's on top. So if I come over to the points here, I need two of them. I will take, let's take the easy numbers here. I'm going to call this one x1, y1, and this one x2, y2. So the slope is going to be 1 minus a negative 3 over, for the second x, 0 minus a negative 3. Ooh, and that makes me realize I made a mistake. Sometimes I do this on purpose. This time I didn't. I actually got my number mixed up. But notice something. I'll erase it. Uh-oh, because I was supposed to do that y take away that y. Instead, I did the y take away an x. So I'm going to come back here and erase that. And I'm going to put the negative 1 in here. And now, when you have two negatives, you make that plus. So the slope is 1 plus 1, and it's 0 plus 3. So that means the slope is 2 over 3. So we now know we can put that in when the slope is 3. So I will set up, actually, I'll put the result over here. Y is equal to 2 over 3x, but I don't know what the slope intercept is yet. So to find that, I have two ways to do it. One of them is that the slope intercept is whatever place where the x is 0. So if the x is 0, this already tells us that the y is 1, so I can just put plus 1. I also can do it this way. Y equals 2 over 3x plus b. Pick any one of these 4 points and plug it in for the x and the y. So I'm going to do that. I'm going to put in, which one do I want to use? I guess I'll use the first one, negative 3, negative 1. Y, oops, I don't use y. So y is negative 1 is equal to 2 over 3 times negative 3 plus b. Well, 3 goes into 3 once, so it's negative 2 equals 2 times a negative, negative 2 plus b. I'll add 2 here on both sides, and that's so that I can get the b by itself. Well, it just so happens that that's what I had over here as well. So that gives me this as my equation. So we'll graph that in the normal way where we start with the y-intercept. So we go to where plus 1 is. I'm going to, this is a little easier to see here, plus 1. And then we use the rise over run of 2 and 3. And they're both positive, so that means we're going to go up 2 and then over 3. 1, 2, 3. So with plus 2 and plus 3. And then I can do it again, 2 and 3. And I can't do it another time. I can, though, also take that and I could make them negatives. Negative 2 over negative 3. That would let me go down 2 and over 3 towards the negatives. Down 2 and over 3 to the negatives. That gives me lots of points to draw along, which is good because I'm graphically challenged. All right. This is a function because every one of the x values along here have only one y value that matches up with them. Every one of them has only one y value every time. And that makes it a function as opposed to just a relation. It's a relation that's a function. Function notation, using it. Here we are told, or we're being given this, f of x. That doesn't mean f times x. What it means is the result, the function when the x value is equal to, when x equals negative 8. That means we can put the negative 8 inside here. So I would write the function negative 8 is equal to 3 negative 8 minus 5. So the function when x is negative 8 is negative 24 negative 24 minus 5. And then the function negative 8, times negative 8 is equal to, I think that looks like a negative 29. Okay. Let me double check my negatives because I got so many of them. That negative, yep, so there's a negative here, negative 8. 3 is positive. 8 times 3 is 24, and it's negative. And we'll subtract 5. 2 negatives getting to further into the negatives. So that's our answer. Now notice, not doing this. Look, divide by negative 8, divide by negative 8. No, 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 no. No, 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 don't do that. Because that's not what the purpose of this is. So I'm going to do, no. Because this negative 8 is not a number. It's just saying X is, you're using X with that. Or rather, that's replacing X. It's not something you calculate with. It's just a notation. It's telling you that when X is negative 8, we get this result of negative 29. So we get a coordinate point that we can put on a graph. And that's the result of getting, of using the negative 8. So you don't do anything with this left side. Don't touch. There. You don't touch the left side. Left side. It's only notation telling you what the X is. Well, now having said that, let's use that over here. We're going to use negative 8 in a different type of problem. So the function at negative 8 is equal to negative 8 squared plus 7 negative 8. I put this in on purpose because the mistake that many people will do is that they'll assume that that negative is this negative, and they'll only put one negative. So they'll either do something like negative 8 squared, or they'll do negative 8 squared, or they'll look at it and do negative times negative and make it positive 8 squared. They won't write the positive, but they'll say, oh, negative times negative is negative. None of those at all. Just don't do any of those. Follow the order of operations. Think about the fact that that's negative 1 times this negative 8 that's now being squared. Exponents come first. So that's negative 1 times, well, negative 8 times negative 8 is a positive 64. Now, because of this negative that's on the outside of it, now it becomes a negative again, negative 64. So what I have is that the function of negative 8 is equal to, after all of this here, negative 64 plus 7 times 8, but it's minus, it's negative 56. So that means here that the function, when we use negative 8 for X, is negative 64, take away 56, which is 110, 120, I believe, negative 120. Okay, so yellow these here. Good. And we could make this a point on the graph that when X is negative 8, we get the Y value of negative 120. And this is a parabola, so wherever it graphs, however it graphs, it's going to hit that point, negative 8 and negative 120. This one over here is not a parabola, it's a straight line, but it's still going to go through the point negative 8, negative 29. Okay, so hopefully that helps with recognizing that things to do with function notation, and that the notation is not something you calculate, just the result of it on the right side. Looking at the ways to show a function, you want to make sure you can actually say these things so you can tell me them later, and recognize the difference between a function and not a function, primarily that there's only one and only one output for each input or X value. Hopefully that helps you. Thank you for watching and listening.